Okay, Yuhei, are you ready? You have your slides up. So we're very happy to have Yuhei Miyauchi presenting matching and agglomeration. And just recall that everybody should just ask a question if you have one. No need to go through chat. We've found that that works pretty well, and it's not, if anything, we have too few questions rather than too many. So go ahead, and you have an hour.
Yeah, thanks. My screen is shared, right?
Yes. We see it.
Okay, great. Thanks. Thank you very much for the invitation. I'm excited to present my paper, Matching and Agglomeration, Theory and Evidence from Japanese Firm-to-Firm Trade. And some of you may have seen the previous versions of the paper, and I'm excited to share some new results. Okay, so the paper starts with a very simple observation that firms are more productive in more densely populated areas. And there's a broad consensus that a non-trivial fraction of this correlation comes from agglomeration spillovers, so the causal effect of population density both from reduced form exercises and structural exercises. And at the same time, there are many theories of the mechanisms of agglomeration spillovers. On the other hand, there's limited empirical evidence on each mechanism and how it matters for spatial equilibrium policies. And the last point is particularly concerning because when, presumably, depending on the type of policy you have in mind, the mechanism may affect your policy implications. So what I'm going to do in this paper is to highlight a particular channel of agglomeration mechanism, which is supplier matching. So this is one of the most classical idea proposed by Alfred Marshall more than 100 years ago. But it has been probably least studied agglomeration mechanism, partly lack of data. So what I'm going to do more concretely in this paper is to ask the following questions. First, I'm going to ask if there's any evidence that firms in denser areas actually benefit from faster and better supplier matching. And second, if there's evidence, how much does it matter for spatial distribution of economic activity? And lastly, I'm going to ask if it matters, how does it matter for the welfare evaluation of highway networks? One type of policy implication that I want to consider. So let me start with the reduced form evidence. The paper, sorry, let me just actually move it here. Okay, the reduced form evidence. The data I'm going to use to document reduced form evidence is the data of the yearly panel of firm-to-firm trade data in Japan, which has been used by several authors already, but I'm going to talk about the nature of the data a bit more detail later on. And using the data, I'm going to document in the cross-section, firms tend to have more suppliers in denser areas. So this is suggestive of that type of agglomeration mechanism I have in mind, but obviously, we may be worried about the endogeneity of this correlation, particularly due to the firm selection based on input demand or production structure. So firms which are in denser location may be simply a type of firms which require external suppliers for production. And so to overcome this selection challenge, what I'm going to do is to study supplier matching after unanticipated supplier bankruptcies and study how quickly firms rematch with a new supplier and how this matching rate depends on the supplier density. So why is this helpful? So these are firms which used to have a supplier, but suddenly lost one. So they are in demand of an alternative supplier. And I can compare these firms, which I know that there's a demand, and how quickly they match with a supplier, depending on the environment. And Japanese firm-to-firm trade data provides a nice setting to execute this empirical design because the data records the list of bankruptcies with their primary reasons. And from there, I'm going to pick the reasons literally labeled as unanticipated bankruptcies. So here's the preview of the results. First, I find that supplier rematching rate indeed strongly responds to the density of suppliers. But second, on the other hand, the density of other buyers does not decrease the matching rate. So what does it mean? More suppliers improves the matching rate, but more buyers does not decrease the matching rate. So indicating that there's evidence of increasing returns to scale in matching technology. Okay. And the third results that I'm going to present is that being matched with a supplier, which is instrumented by supplier bankruptcy, significantly increases sales. So being matched with a supplier is important for your production. But there's no significant heterogeneous effects with respect to supplier density. What this is implying is that the benefit of having a supplier is not different across, per matched supplier is not different, significantly different across different supplier density. The benefit of supplier matching seems to be coming from faster matching rate rather than better suppliers. So having these reduced form evidence in mind, what I'm going to think about next is to think about how this reduced form evidence what this reduced form evidence imply for the spatial equilibrium. And to think about this, I'm going to build a model that incorporates dynamic search and matching in input rate, following Diamond-Mortensen Pizarro's type of framework, into a canonical quantitative spatial model. So just like a standard quantitative spatial model, the model is going to incorporate rich location heterogeneity in productivity, amenity, bilateral trade, which is important because I want to do realistic counterfactual later on. But on top of that, the location productivity is going to endogenously depend on the supplier matching because of that search and matching part. And I'm going to structurally estimate the model to fit the gravity equations of trade flows, which is predicted by the model. So it's a nice feature of the model as well. And also the impacts of unanticipated supplier bankruptcies that I documented in the reduced form exercise. Okay. And using the estimated model, I assess the importance of supplier matching for shaping the spatial economic activity. So one thing I'm going to show is that the supplier matching mechanism contributes to location productivity in wages at a comparable magnitudes as a typical estimate of productivity spillovers from population density. And so this kind of elasticity has been estimated by many papers. And you can think of this as a composite of different agglomeration mechanism. So what this is saying is that the supply matching mechanism seems to be quantitatively relevant compared to the typical estimates of the composite of agglomeration spillover terms. And second, perhaps more interestingly, I think about, I study the welfare implications of the highway networks. And what I find is that while supplier matching mechanism significantly increases the welfare effects of these highways, there's no such effect if productivity spillovers only come from local population density. Okay? And the intention behind this is kind of, simple. The supply matching mechanism of agglomeration is generated by the density of suppliers, where that density of suppliers includes suppliers which are also producing outside your location. Okay? So by improving the transportation access across locations, you're going to increase the supplier density, which are also coming from other locations. But there's no such effect if the productivity spillovers comes only from the local population density. And that's why these two leads to a very different qualitatively and quantitative conclusion for an important policy. So that's where we are going. I'm going to be very quick for the related literature. So obviously there's a long history of economics of agglomeration I'm citing a couple of papers related to the level evidence. But what is probably more related to my paper is the paper that talk about supplier matching as a microfoundation of agglomeration. And evidence is relatively sparse, and probably the closest one is Tom Holmes' 1999 paper, which documents the positive correlation between population farm density and externally sourced input expenditure. So I'm going to build on his insight using quasi-experimental variation and a new spatial equilibrium model. And the paper is related to quantitative spatial models, particularly focusing on transportation infrastructure, search and matching frictions in trade, as well as farm-to-farm trade networks papers, some of which have been presented in this sequence of seminar series. All right, so here's the outline of the remaining talk. I'm going to talk about data, reduced form evidence, and then talk about the model and estimation, unless there's any questions at this point. Okay, so let me just continue to the data. The data has been used by several papers, including Andres and Andy's paper. It's a yearly panel of farm-to-farm trade in Japan over 10 years. It's constructed by a credit reporting agency called Tokyo Choco Research. It covers 70% of all firms, 90% of firms, about 5 employees. So it's not a census, but it's close to census if you look at relatively large firms. And it covers all sectors: manufacturing, retail, wholesale, construction, and services. So that's, I'm going to include all of them in my sample. And most importantly, for my analysis, each firm reports up to 24 main suppliers and buyers each year, which is collected based on interviews or survey. Okay. So this is nice because I can study the dynamic evolution of trade networks, but there are 2 limitations that I have to be upfront at this point. One is that it's only about the extensive margin. So it doesn't contain the information of the volume of trade, for example, like VAT data. And another limitation is that trade information is only available at the firm, but not at the establishment level. Okay, so keep that these caveats in mind. And we're going to exclude links which have ownership linkages because they may operate in a very different mechanism. And also in my baseline analysis, I'm going to use the buyer-reported supplier linkages and include supplier-reported buyer linkages for robustness. So before getting to the main reduced form exercise, here's the kind of the first cut evidence of cross-sectional evidence of the supplier matching mechanism as a foundation of agglomeration forces. So here what I'm plotting is on the x-axis, the population density, and y-axis, the number of suppliers that each firm has, which is weighted by the sales of the firm. And each dot is a municipality. So you see a positive correlation, which is the same correlation essentially as, or almost similar correlation essentially with Holmes 1999. But we are worried about the selection story. Again, like firms, this may be driven by the fact that firms which are located in denser locations are type of firms which require externally sourced inputs for production. Yeah.
So I have a question. So how do you determine the location of the firm, especially with multi-establishment firms in there?
So
you know what I mean?
I define it as the headquarters of the firm. And this graph is also using that. And when I get to the reduced form exercise, I run a robustness check by restricting single establishment firms. So okay. I know, So that's.
And so you know if there's if they have multiple establishments in the thing.
I know the establishment location information. That the thing that I don't know is whether trade is initiated at a particular establishment.
Got it.
Thanks.
Yuhei, I also have a question about, do you look at different sectors? Like, I would imagine the retail would be specific, subject to concern that denser population might require more varieties.
Yes, yeah, so I haven't, I don't remember how this particular graph looks if you separate retail versus manufacturing. In the reduced form section, I did some analysis, and I can mention that, and just remind me if I forget to mention that.
Okay.
Okay. Let me. So, anyways, so the design that I want to implement to go beyond this cross-sectional evidence is to look at how quickly firms match upon an event of an unanticipated supply bankruptcies. Because those in these cases, I know that they are in demand of an alternative supplier. All right, so let me get to the reduced form.
Okay, so I have another question about that.
Yeah, okay.
What's a bankruptcy? Like, does that mean, like, American Airlines goes bankrupt all the time, but they keep flying? You know what I mean? So
yeah. So let me get to the next slide and mention that as well. So the list of the data provides a list of bankruptcies with their primary reasons, and from there I pick literally labeled category, which is unanticipated reasons, which is 1.5% of all bankruptcies, and which is described as unanticipated accidental problems such as the death of representatives, flood, disaster, fire, earthquake, and so on. Okay. And I'm going to exclude reasons related to like sales decline or data accumulation because they seem to be endogenous to the buyer side firms. And coming back to Mike's question, maybe a related number that I can give you is that in the data, I observe exit of the firm, whether the entity of the firm actually disappears. And it happens for the case conditional on bankruptcy, it disappears for about 80% of the cases. So if you want to, it includes potentially firms which keeps operating. So if you want to kind of, do the IV version of the regression that I'm going to do, you have to scale by 0.8. All right, so so the design is to look at the impact of unanticipated supplier bankruptcies and on the number of new suppliers they are going to match. Okay, and for that, I'm going to implement a simple difference in difference design, where I take which is based on the following regression, where I is the firm, T is the year, and treatment takes 1 if firm I faces an anticipated supply bankruptcy at some point. And G is the group of matched control and treatment firms, where control firms are assumed to have to be headquartered in the same municipality, and also have a supplier in the same 4-digit industry. Okay. So essentially, these are the firms which are plausibly facing the same local supplier market. And if I select control firms in this way, control firms and treatment firms seem to be balanced in terms of pre-period characteristics. So it seems that it's also confirming that these shocks are actually unanticipated. And post is the post-treatment dummy. So beta is, then the outcome variable is the number of new suppliers, which is essentially the number of suppliers which are not connected in the baseline period, right before the shock. Okay. So beta is the number of suppliers treatment firms match more relative to the control firms. And I include the group and year fixed effect to make sure that the comparison is within all these groups. All right, so here's the impacts on the number of new suppliers. Okay, so in the form of event study graph. So there's no pre-trend, but right after the shock, so these are the x-axis, the years, and since the unanticipated supply bankruptcy shock. So right after the shock, firms start to rematch with new suppliers, relatively more compared to the control firms, which didn't face supplier bankruptcy. Okay, So they do rematch with a supplier, but these are significantly less than 1, okay? Which indicates that the matching is not perfect. Okay, so that matching is low. And these patterns are similar regardless of how you treat exiting firms or not. So it seems that firms are matching with new suppliers by this shock, which is confirming my my presumption that firms are in demand of an alternative supplier, but they may be facing some matching frictions. So what I'm going to study now is to look at how this matching rate differs by the supplier density.
Yuhei, I've kind of a broad question. How much, you're looking at firms that lost a particular supplier because of unanticipated bankruptcy. How pervasive is churning among suppliers? Are we looking, is this a major source of changes in suppliers, or is it?
Yeah, so this is a very minor fraction of bankruptcies. And I'm using this because of the identification reasons. And I should be able to answer the churning rate, which I'm forgetting. I think the churning rate, including all exits of suppliers and the separation with suppliers, you know, even if suppliers exist, they may separate the link.
Sure.
That's something like 50% of the links are destroyed over 8-year periods or something.
Okay.
Yeah, so it's that shock that I'm looking at is not very frequent, but the separation shock itself is relatively it's not not infrequent.
Mhm.
Can I follow up on that? Which is, how different does your event study look if you condition on just any separation? It must be that when you lose a customer, that you're going to add a new buyer. Is it very different?
Yeah, so that's a good question, and I've tried several times, but it's you get very strong pre-trends, and it's really kind of hard to interpret what's going on. So so that's why I kind of we decided to restrict only on these events. So the short answer is like you're gonna get a very strong pre-trend, and if you can interpret bilinearly and try to make up some numbers, but I didn't think that's convincing enough anyways. But that's a good question. This type of shock may affect the response differently for maybe other types of more endogenous shocks.
Okay.
But anyways, so having confirmed that firms are actually do match with new suppliers, what I'm going to study next is to look at how this matching rate depends on supplier density. Okay? So here I'm including the interaction of post times treatment and the supplier density, where supplier density is defined by the density of firms in bankrupt supplier industry, which has a buyer in the treatment firm's headquarter prefecture in 2008. Okay. So these firms are already supplying to these to the location of buy, so they are presumably reasonable alternative for as a supplier. And to make sure that this gamma does not pick up the heterogeneous effects, which come from other dimensions of firm heterogeneity, I include various controls as an interaction with treatment and post, including location fixed effects to make sure that the comparison is within location across different supplier sector or industry fixed effect or firm sizes. But you may be still worried about the endogeneity concern, and a particular type of concern is firms which have a higher ability of finding an alternative supplier may tend to locate in a denser supplier market. Okay, so in this story, there's a kind of omitted variable here, and that is correlated with supplier density, even after you control for ZIG. So in the paper, I tried to address this question using the instrument for supplier density. And let me give you kind of a high level idea, because I also want to make sure that I can get to the model. The idea, so when you think about the ideal experiment, to think about the candidate of ID, is that ideal experiment is we want to randomly assign firms to different supplier density locations and give a shock of supplier bankruptcy and study how they respond differently. So that's not what I can exactly create, but I can create a similar type of natural experiment based on the observation that firms' location choice depends not only on the supplier access concern, but also on the buyer access concern, which is the other side of the market. Okay? So this idea is coming from Redding and Venables as well. And the idea here is that firms' buyer access is plausibly uncorrelated with unobserved supplier matching rate, which is the other side of the market. So the basic idea of the IV is to define supplier density, evaluate it at the firm's ideal location only from the perspective of the buyer access. Okay. So just to be explicit, the procedure is to pick the most common industry among each firm. So I'm going to call this B of I as a typical buyer of the firm, the typical buyer industry of the firm. And I'm going to identify the location where these firms in this sector are highest. So this is the location for the firm I, which is ideal for the perspective of buyer access. And I'm going to evaluate the supplier density at this location, which is ideal for the buyer access perspective, instead of actual location of the firm. Okay. So here's the first stage of this idea. If you look at the supplier density evaluated at actual location, it is significantly correlated with the supplier density, which is evaluated at the ideal location for buyer access perspective. So it is essentially saying that firms have tendency to locate in a location which have good buyer access, which is consistent with Redding and Venables. And even after you control for the supplier density, evaluate it instead at the ideal location for supplier access perspective, you get significant effects.
Yuhei, can you justify a little bit more the uncorrelated? I mean, wouldn't a denser place have more buyers and suppliers?
Yes, so that's exactly why I want to control for this term, which is that I also simultaneously control for the supplier density, evaluating the ideal location for a supplier access perspective. Okay, so if you're right that by this procedure, I'm kind of picking up location which are dense, where like there are a bunch of buyers as well as a bunch of suppliers, but I'm also controlling for the supplier density, evaluate that at the supplier access. So there should be an independent variation that is only coming from the component of the buyer access.
Okay, I have a follow-up question. I think I'm not sure how detailed your industry is. Most of the input-output will be strongly on the diagonal. So I've been wondering what assumption you need, to say, maybe you need to have some like independent variation of the buyer's access, buyer industries, shock that should be orthogonal to whatever impacting the supplier shock. I wonder how reasonable that is, given this most of the input output will be within industries, right? Most of the time. So I've been wondering what's the exogenous variation there that we could think about.
Yeah, so Daniel's question is exactly right. So there shouldn't be independent variation if your matrix is all diagonal. Okay, so the fact that I actually get independent variation is is exactly coming from the fact that it's not entirely diagonal. And I guess like that's pretty much what I can say, and I can try to check what are the frequencies that this buyer industry and supplier industry is the same. But I think that check is something that I haven't done. All right, so let me let me just get to the results. I have to, I'm a little bit pressed on time, so I want to push forward. So here's the results of the heterogeneous matching rate with respect to supplier density. First column is just the average impact of supplier bankruptcy on new supplier matches, which is exactly the thing that I showed. And from second column, I show the interaction with supplier density. And so, and these are standardized to have mean 0 deviation, standard deviation 1. So you should be thinking of these magnitudes as 1 standard deviation increase, how much the average treatment effect increases by 1 standard deviation increase of these proxies. So they are significant. They are significant even after you control for location fixed effects, supplier industry fixed effects, and using the implementing this IV, as well as also controlling for firm sizes if you still think that there are still omitted variable concerns at the firm level. Okay. So that's one set of results. The second result that I want to show is how the matching rate depends on the density of buyers in turn. Okay. So here I'm interacting the supplier density, heterogeneous effects of supplier density, but on top of that, I'm including the density of buyers. Okay. And now it's not obvious how you define density of buyers. So I tried different proxies. One is the buyers which face supplier exit recently, buyers which faces supplier separation recently, or just the number of firms in your industry. And none of them seem to be significant and reasonably estimated to be close to 0. And most importantly, if you test the hypothesis of the sum of supplier density and buyer density, you can reject the null that they sum up to 0. So it's I take it as evidence of increasing returns to scale in matching. The last evidence that I want to show is the impacts on the number of sales. And to do so, I'm going to implement this regression where the left-hand side is the firm level outcome variables such as sales on the number of suppliers and number of suppliers interacted with supplier density instrumented by this shock. Okay, so I'm translating the loss of a supplier and also partly it's recovered on the changes of number of suppliers and how it affects the firm level outcomes. So having more suppliers increases sales significantly. This is normalized at the baseline level, so you should be reading this as 6% increase per 1 supplier. And but this is significant, but this effect is not heterogeneous with respect to supplier density. Okay? So the value of a match, so to speak, is not different across different supplier density. And I also studied the response to employment or profit and profit to sales ratio, but these seem not to be significant. So just to recap the reduced form evidence, the evidence that I showed is there's imperfect recovery of suppliers upon supplier bankruptcy, but the matching rate with a new supplier increases in the supplier density. And the second evidence is that density of other buyers does not affect supplier matching. And lastly, matching with a supplier benefits firms through increase of sales. So with this reduced form evidence in mind, what I want to do now is to get to the model to think about how this evidence translates to that spatial equilibrium.
Okay, so let me, before you, I want to see the model too, but I do want to like kind of, I mean, is this definitive evidence that there's increasing returns to scale? Or, I mean, that's what, like when I was looking at the paper too before the talk, like I think that's the weakest. Like I kind of see what you're saying, but at the same time, it has some kind of hesitation. I don't quite completely follow the argument that there's definitely increasing returns to scale here in the matching function. You know what I'm saying?
Let me say one thing, and I'm not sure whether this is going to answer this question. So one thing that is not actually in the paper that is posted in my website, and I'm going to show the updated version of the model, is to incorporate the decision of buyers to accept a match. Okay, so that is the margin that is so here in the data. What you observe is that is the matching and also accepting a match. So what I'm saying is that there's increasing returns to scale matching of the product of these two, but it's possible that like the matching technology itself doesn't have this increasing returns to scale. So so if that is your concern, I would like to proceed to the model.
See it.
Yeah, sounds great. Thanks. Happy to talk afterwards if you're thinking of something else. Anyway, so the model is going to have multiple locations denoted by INJ. There's going to be a unit measure of people deciding their residential location. And there are continuum of firms in each location. And here, when I say a firm, any firms can be a supplier and buyer at the same time. So it's a firm-to-firm trade network context. And I'm going to present a single sector model, just primarily for the presentation purposes. And in a single sector model, each firm matches with at most one supplier at a time. But suppliers can be matched with multiple buyers simultaneously. Okay, so it's a one-to-many matching environment. When I get to the multiple sector model, it's going to be one-to-many matching within each input sector. And time is continuous, denoted by T, but I'm going to focus on the steady state equilibrium where aggregate variables are constant. So T is dropped in many of the aggregate variables. All right, so let me start with the production technology. So each firm has a Cobb-Douglas production technology where the unit cost is going to depend on the exogenous productivity of the firm, wage, and intermediate goods price, okay, where gamma is the share of intermediate goods used. And the intermediate goods price is determined, there are two ways to source intermediate goods. One is to form a long-term relationship with a supplier, and the other is to produce in-house using local labor. Okay? I'm going to explain this in more detail later on. But before getting that, let me explain that distribution of productivity. So the measure of firms in each location is determined as in the following expression, where the measure of firms above productivity some level var5 has a power law functional form, where A tilde I is going to be some location productivity, because if A tilde I is higher, there are more firms which are more productive. Okay. And I'm going to assume that this A tilde I has two components. One is the exogenous productivity of the location, and the other is the component which depends on the population density. Li is the population, Zi is the geographic size of the location, where the elasticity is iota. Okay. So this is a typical way of modeling agglomeration spillovers in this kind of quantitative spatial model. So what I'm going to do after estimating the model is to run a horse race between this channel and the supply matching mechanism that I'm going to build. And it turns out that the distribution of unit costs in the steady state also follows the power law, which has the same exponent. Okay. Where gamma I now captures, which I sometimes call comparative advantage term, it now depends on productivity of the location, wages, as well as the supplier matching part. And I'm going to explicitly derive what is gamma I after explaining the such a matching component. All right, so let me start talking about the market. And the final goods market is very standard. It's a Melitz model. Final goods are traded with iceberg trade cost with tau ij. they're gonna pay a fixed cost FJ in terms of local labor to sell in location J. And representative consumers have CS utility and they are under monopolistic competition. So it's gonna define, as we all know, that the trade flows follow a gravity equation where the source location fixed effect is going to be gamma I, which depends on the distribution of the unit cost at the production location I. So that's standard. So what's new about this model is the search and matching in intermediate goods market. So here's the basic timeline of what happens in this market. Again, there are two ways to source intermediate goods. One is to form a long-term relationship with a supplier, and the other is to produce in-house using local labor, where I'm going to assume that zeta is, in order to produce 1 unit of intermediate goods, you have to use zeta number of local labor. So your unit cost of, if you choose this option, is zeta times WJ, where WJ is the wage. And first, I'm going to assume that a fraction of firms, delta fraction of firms, can ever match with external suppliers. Okay. So this is not really important for the economic logic of the model, but it's important to rationalize the relationship between steady state matching rate, the dynamic matching rate with a supplier, and separation rates in a quantitative sense. And if you are a type of firms which can match a supplier with a supplier, and also if you don't have an ongoing relationship with a supplier, you're going to meet with a new supplier, potential supplier, at Poisson rate VJ. And firms, I'm going to describe how VJ is determined in the next slide. And if you draw a supplier, they are going to decide to form a relationship if the joint surplus exceeds the option value of weighting. Okay. So implicitly, what's going to happen is they determine the acceptance threshold of depending on the supplier's unit cost, C upper bar. And I'm also going to derive this by solving the Bellman equation later on. And the relationship is exogenously destroyed at some Poisson rate, rho J. So overall, this is like a standard Diamond-Mortensen Tsarides type of world where, instead of labor market, it's the intermediate goods market. So how is this VJ determined? The Poisson rate of matching determined? I'm going to introduce the matching technology to define this relationship. Okay. So the matching function is going to describe the total matches created per area. And this is going to depend on the density of suppliers and density of buyers. Okay. And the density of suppliers in location J is the set of the measure of suppliers whose unit cost, net of trade cost, is below the in-house production cost for intermediate goods. So these are the firms which have some possibility, if they get matched, they're going to use the suppliers. So there's a potential gain of matching. And BJ is the density of buyers in location J, producing in location J, who are currently not matched with a supplier and whose unit cost is below some threshold.
So do you ever, can your buyers find a new supplier who's more efficient and dump the old one?
No, there's no on-the-job search matching type of thing.
Because it would seem like a straightforward extension, and an interesting question would be whether there's more churning where there are denser suppliers.
Yeah, that's a good question. I'm choosing this modeling choice, partly because this type of model explicitly matches with the reduced form findings more in a much more straightforward manner. But I agree that that's a kind of interesting extension to think about. Right, so this matching, sorry, I didn't finish this var theta parameter. This parameter is not really important. This is just introduced because remember that this is an environment where there are infinite number of firms. If you go to that very lower tail of the distribution, so I have to set some parameter to define a finite number of buyers. And the matching rates of buyers to suppliers is just the matching function divided by the density of buyers. And note that I'm allowing lambda plus nu does not have to be equal to 1. Okay? And in particular, if lambda plus nu is greater than 1, that means that the matching technology has increasing return to scale. Okay. So coming back to Mike's question, that's after estimating the model, that's probably more of the right test to run for the increasing returns to scale in the matching technology itself. All right, so to derive before deriving Bellman equations, one last thing that I have to do is to be precise about the bargaining procedure. And I'm going to assume efficient Nash bargaining. And efficient bargaining implies that two firms are going to make a joint production decision if they are forming a relationship, which implicitly implies that intermediate goods is traded at the supplier's unit cost to avoid the double marginalization. Okay. But on top of that, I'm also going to assume more important assumption, which is I'm going to assume that buyers have all the bargaining power. Okay. And the reason why I'm introducing this is if you relax this assumption, the joint surplus is going to depend on the entire dynamic evolution of the farm-to-farm trade network. And that's unfortunately not going to be tractable, especially if I want to do aggregation. Okay. And for a similar reason, previous papers such as Felix, Tintelnot, and others paper assume that there's a similar assumption about the bargaining power. Yes. And another assumption that I'm going to make is that suppliers' relation-specific unit cost is fixed at the point when the relationship starts. So remember that suppliers are also matching and their unit cost may be changing over time, matching with a supplier, their suppliers. But I'm going to assume that for this particular relationship, they're going to keep using the same technology at the point that they have access to. And so what this buys me is basically that the current unit cost of the supplier is going to be a sufficient statistic for the buyers to determine whether they accept a match or not. All right, so all of these assumptions allow me to describe the Bellman equations and to determine the decision of buyers to decide whether to form a relationship. So here, value of a firm, which is matched with a supplier whose unit cost is C, is V of C, and Xi is the discount rate. Pi of C is the instantaneous profit from intermediate goods with cost C. Remember that they are connected to the supplier at unit cost C. And with some probability, they get separated and they are going to get to the state where they are not matched with a supplier. And what is the value there? The value of a firm without a supplier, in turn, depends on the instantaneous profit when they are using in-house intermediate goods at the intermediate goods cost of zeta times WJ. And with some probability, they're going to match with a new supplier, and they're going to draw from this distribution, and they're going to transit to, and if the value of forming a relationship exceeds the current value, they're going to go to this state. Okay. So it's very standard labor search and matching Bellman equations. And note that Fj of C, the distribution of unit cost of suppliers, follows the Pareto distribution. Okay. Because of the unit cost of production follows the power law. And another assumption that I made is profit only comes from final goods sales, okay, because buyers have all the bargaining power in the intermediate goods market. And what is the final goods sales, profit from final goods sales? That is proportional to to the supplier's unit cost C. Remember that that market is just a standard millage model. I have to make an assumption that the fixed cost goes to zero to make this actually a power function. Otherwise, there's a kind of entry marginal firms which decide to enter or not, and that's not going to give you the power function form. But if you're happy with this this assumption, these instantaneous profits are power function, and the distribution of suppliers are follow the Pareto distribution, which allows me to analytically solve these two equations. And what you're going to get is the acceptance.
Sorry, can I ask just a clarifying question on the previous slide?
Yes.
You're integrating over the density of suppliers' costs. Does that mean that the probability of being matched to, say, a large efficient supplier is the same as a small one?
That's the assumption that I'm making. Exactly. Yes. That is so in the reduced form exercise, I didn't show it today, but if you look at the how the supply matching rate depends on the size of the firm, it doesn't seem to be significant. So that's partly supported by the data, but you know,
right.
that's
the reason why I'm asking is because presumably large firms have more customers.
So
why would that come about in the model?
So that can be rationalized because if you are matched, if you are an efficient firm, you are more likely to be counted as a potential suppliers in many other locations. But that's the only margin where that pattern comes from. So so I'm not sure quantitatively that can rationalize the pattern, that cross-sectional distribution, which I'm interested in checking later on. Thanks for the question. Okay, so but this defines the acceptance probability. I'm not going to explain like you know, it's a little bit complicated expression, but it's intuitive. For example, if the matching rate is fast, you're going to accept less because you know the option value of weighting is higher. If Guzai, which is the discount rate, is high, you're going to accept more because you don't care about weighting. And this acceptance probability is going to define the acceptance threshold. Again, the fact that you accept more means that you are happy with lower with a supplier with with higher intermediate goods cost. And this also allows me to derive the expected increase of profit if you get matched. This is decreasing in AJ. Again, this is coming from the fact that if you accept less, that means that you are more selective. So conditional on forming a match, your profit is more likely to increase. And last, and using this, I can get the steady state match probability where delta is again the fraction of firms which can match with external suppliers. V times A is the match realization rate, and rho J is the separation rate. And the model is going to predict the gravity equations, which is kind of related to, I think, Cecilia's question. Where the conditional supplier's unit cost matching rates with a buyer is the same. And because of this assumption, following a similar logic as the Millitz model with Pareto distribution, you're going to get the gravity equation, which is entirely driven by the extensive margin. And it is the same gravity equation as the final goods market. And lastly, the labor mobility assumption, which follows standard from a quantitative spatial model. The utility depends on exogenous residential amenity, wage, nominal wage divided by price index, and population size, where there's some dispersion force. It can be coming from any types of dispersion force. And I'm going to assume that this utility is equalized across locations, which is going to define the population size in each location. So just to recap, the steady state equilibrium is defined by gravity equation trade flows, such as matching and intermediate trade goods flows, trade balancing, and free labor mobility.
Could I just have a quick clarifying question, Yuhei? In your model, the buyers, are they also intermediate good producers?
Yes, they are. They take the same role.
Then I've been wondering, I was thinking you do have an additional, but the buyers can sell to multiple places. I was just wondering where that got reflected in your value function, because
yeah, so that's again the assumption coming from the assumption that buyers have all the bargaining power in the intermediate goods trade. So what that means is that suppliers are not going to get anything, any profit from the intermediate goods. Yeah, so that's exactly why this assumption is required. Otherwise, it's that part is going to enter here, and it's not. It's kind of impossible to solve the model.
Got it.
Okay, so I guess I have 3 minutes. So let me just kind of convey the main message of the paper using this slide. So what I want to convey in this slide is the main logic of the agglomeration force in this model. So gravity equation of trade flows have this form where this gamma comparative advantage term has this nice expression, okay, which depends on the exogenous productivity, which depends on the local population density spillovers, which depends on wages. So far, it's the standard quantitative spatial model. And on top of that, there's a term which depends on the supplier matching, which depends on the match probability in the steady state and the benefit of a match. Okay. So in the end, this is a this is a matching market. So you can imagine that these two are, margins are going to determine the benefit of a match that contributes to location productivity. But now if you stare at this equation, this lambda I is also going to be in turn affected by gamma I. Why? Because lambda I has this expression which is increasing in the matching rate, where the matching rate is going to be increasing if your location is surrounded by a location, including your location, which is more productive. And this elasticity is lambda. There may be potentially some crowding out because as there are more buyers, the matching rate may decrease. But if this crowding out is not strong enough on net, the matching probability increases, and that is going to enter here, and that gain increases gamma I. Okay. So this, if you look at this, so what I'm going to do, or what I do in the slides after this slide is to first estimate all of these parameters, and I can answer the questions later on if there's an interest in exactly what I do. And separate first. One thing that I do is the decomposition exercise of this gamma I. I estimate the gravity equation from using the farm-to-farm trade data, and I get this gamma I directly from the data, and I can decompose these different margins. And this component, which is related to supply matching, is comparable in magnitude compared to a typical estimate of IOTA, which is the local population productivity spillovers. And I'm also going to show that in a counterfactual of changing the trade cost, which is going to affect here. Okay. How does the welfare gain changes by shutting down this mechanism of agglomeration and the matching mechanism of agglomeration. And it turns out that setting IOTA to 0 actually doesn't change the welfare estimates that much. While setting this this channel is going making this to 0 is going to substantially decrease the welfare gains of the transportation infrastructure, and that's relatively straightforward to see in these equations, because this counterfactual is going to shock here, which changes the matching rate, while this local population density spillovers are not affected directly by this type of counterfactual. So, so that's what I do in the rest of the slides. I can come back if there's an interest, but for to keep that keep myself on time, let me just conclude. So this paper is about supplier matching. I showed, and also agglomeration. I showed the reduced form evidence that firms match with suppliers at a faster rate if facing higher supplier density upon unanticipated supplier bankruptcies, and build a model of Diamond-Norton Simplicity type dynamic search and matching in input rate in a quantitative spatial model, and to fit the reduced form evidence to the data, to the model. And I show that supplier matching quantitatively and qualitatively relevant for understanding spatial economic activity and for the impacts of transportation infrastructure. Right, so let me stop here. Sorry that I had to rush toward the end, but I'm happy to hear any of your feedback.
Yuhei, I have a question. Since you rushed at the end, and maybe you said this and I just missed it. So did we see the gamma and the nu that you estimated?
No, sorry, I had to kind of rush through.
So my question is,
no, you're not missing anything. So maybe this slide is something I should have shown. So estimation procedure has 4 steps. One is calibrate a subset of parameters.
mm-hmm.
And second is to estimate gravity equations of trade flows. And third is estimation of matching parameters. And fourth is estimating exogenous productivity term at each location.
Mm-hmm.
Let me go quickly. So a subset of parameters that I'm going to calibrate from the literature is relatively standard input-output table related parameters and elasticity of substitution and so on. And gravity equation is also standard. I'm going to assume that bilateral trade cost is a power function of travel time. And I'm going to get origin and destination fixed effects. And so this part is kind of the most relevant part that I think you are asking.
Mm-hmm.
So to estimate the matching parameters, I'm first going to get separation rate directly from the data. And I'm going to set parameters. I'm going to get these matching related parameters. And given these parameters, I can use a model structure to back out steady state match probability, also sales weighted sales match probability, matching rates, acceptance rates, proportional sales, increase of sales from a match. Except for these parameters, all other variables are either estimated from the gravity equations, such as omega, gamma terms, or directly coming from data. And what I'm going to do is choose these parameters that minimize the Euclidean distance to some of the cross-sectional moments, the steady state matching probability with a supplier, and also the regression coefficients for the average and heterogeneous impacts of unanticipated supplier bankruptcies upon on supplier matching and sales. Okay. So why is this informative? Because in the model, I interpret supplier bankruptcy as an exogenous separation with a supplier. So I can give a shock in this model, and the match realization rate is V times A. Okay, so that's related to Mike's previous question. And I can run a regression of V times A on supplier density or buyer density to replicate exactly the same regression that I ran in the reduced form exercise. So that's the kind of the intuition of what I do in this estimation. And sorry, here's the values of the estimates, indeed. So this lambda and nu are kind of key parameters, the matching technology related parameters. Again, these are estimated primarily off of the variation from the reduced form regression results of the matching rate and heterogeneous matching rate with respect to supplier density and supplier buyer density.
So if lambda and nu, are those the things together that determine the increasing returns? Do I add those to get the degree of increasing returns? Is that
Sorry, I don't think I understood your question.
so you have these two elasticities of matching with supplier density and buyer density?
Yes, that's lambda and nu.
And would they sum to 1 with constant returns?
Yes, if they sum up to 1, that's a constant returns to scale.
Okay,
in matching
so
technology.
that sum gives us the size elasticity.
Exactly. Yes. I mean, it's the model is kind of it's a little hard to project to labor search and matching model because they are trade, and
yeah,
even if the elasticity, even if the sum of these sum of these two parameters sum up to exactly 1, I'm not sure whether it's exactly going to function in a similar way as in the context where there's just one market.
mm-hmm.
But that's with that caveat, your interpretation is exactly correct.
Okay. Thank you.
But then presumably that it's the fact that that's equal to 1.6 that you're saying can account for a lot of what normally would be explained by just the labor force at each location. It's sort of like
exactly. So that's
and were
so
you saying it was of the same magnitude, or was it kicking out the other effect?
So let me actually, sorry, I have to, I should have done better time management to go over all the results. So, so I guess this is relevant to Sam's question. So in the end, after this estimating these matching related parameters, what I'm going to do is to estimate the exogenous productivity of the location. And the way I do it is use the source location fixed effects, and which is explicitly written in this form. And if you look at this, the only parameter that I know that I don't know at this point is this AIM. So I get all of these terms from the up until step 3. And this expression is going to give me a nice way to think about where the variation of so to speak, comparative advantage terms comes from. And that's exactly what I do. Okay, so here I regress this area adjusted source location fixed effects and project it onto the population density. Okay. And I can do the same exercise for 4 different components and to study where the population density premium is coming from. And this is the results of the regression. And what I want you to look at is this 3rd column and 4th column. 3rd column is the magnitude of the local population density spillovers, where iota, so you can imagine that this iota is a key parameter, which this coefficient is essentially just iota times theta. So you have to kind of think about your favorite estimate to plug in this value. But this one is estimated in my context. And what I was saying by a similar magnitude, similar contribution to the productivity is that these magnitudes are similar.
Right. So these are in addition to the improved supplier matching. You're saying that the 2 are about.
Sorry, this term, the 4th column,
Yeah.
is the matching. Yeah, sorry. This one is is a separate mechanism from the supplier matching mechanism.
And the 2 together are about the same.
Yes. So essentially, this coefficient should. So if you sum up all like 2 to 5, this is gonna sum up to 0.41.
Mm.
And I guess another related point is that if you ignore this term, which is essentially a typical model of quantitative spatial model, you're gonna attribute this term to the exogenous productivity term. And so this is another way of saying that I microfund where the productivity differences come from.
I don't know. I mean, but the hard thing is that the iota stuff is all built into 4 too. You know, because you're showing us that formula as well. But I mean, I mean that's I mean, I think the wage equation kind of does a better job at this. That's my opinion. But the thing is that I think would be more interesting is, you know, you have to take a stand on iota on the on just the pure spillover, right? That's externally calibrated. And what would be interesting is, could you in the data kind of figure out what is the pure spillover versus the spillover coming through the search and matching process? And I don't know. My impression is you can't.
I mean, one way to think about this
to do that.
Yeah. I mean, one way to think about this is assume that population density is uncorrelated with exogenous productivity.
Yeah.
So that's gonna give this type of magnitude. Obviously, that assumption is not something attractive, and that's the whole reason of why people are so, you know, that's a kind of the, I guess, half of the urban economics literature trying to understand whether the population density premium in productivity and wages are coming from the causal effect or, you know, something like natural advantage. So, you know, if I have a good instrument for population density, I would be interested in doing that. I guess, you know, that's a type of instrument that is really hard to get. If that answers your question.
Hi, this is Andrew McCallum. I had a question. Yuhei, about your the bargaining parameter. You said it was set to one of the limits. Which one was that again?
The bargain, yeah. So that's the bargaining power belongs to the buyers.
Okay. The buyer has all the bargaining power.
Exactly.
Got it. So the producer makes. The producer's compensated for the production costs and the like expected search costs. They're all in expected average cost, and that's all.
Exactly.
Okay.
Yuhei, I still miss a little bit. You know, your answer to Jonathan was really useful. I still miss a little bit how you separate those two coefficients. I understand, you know, you need them to add up to something, you know, generate interesting actions. Like, how do you separate in your language the new and that matching function, which is a key, you know, I could vaguely see, you know, your reduced form might play a role, but I cannot connect that directly to where it matters actually.
Yeah, so remember that in the reduced form exercise, I look at the supplier matching rate as a response to supplier bankruptcy. So there, like the average response is this regression coefficient. So after this is the number of suppliers they get treatment firms newly match relative to control firms, and this is the heterogeneous effect with respect to supplier density, and this is the heterogeneous effect with respect to buyer density. Remember that I showed both of them. And so these three are essentially informing these three parameters. Again, it's not mechanical because there's acceptance decision. And what you see in the data is a summation of the matching rates and the acceptance rate. So it's not going to mechanically translate, but that's essentially where these elasticities are estimated off of. Does it answer your question?
Yeah, but it just, for instance, now it's saying that, you know, my match function is more sensitive to buyer density than supplier. Which informs me about that?
Sorry, this the heterogeneous effects. So this is the increase of matching rate for one standard deviation increase of supplier density in that regression, in the reduced form regression. And this is the, I guess I'm taking the probably the most conservative one. And I think sorry, let me just make one caveat that one thing I'm still making progress on is to bootstrap these parameters, because as I said, this heterogeneous effect with buyer density was insignificant. And this is a question, but it is insignificant. So I kind of want to incorporate the uncertainty of the estimates as well. But anyways, the point estimate is minus 0.1. And so that's the kind of the reduced form responses of match realization after you get you face a separation shock with a supplier. And again, these questions are coming from through the lens of the model. These questions are coming from the fact that firms' matching rate depends on is determined by the matching function. And also endogenously, firms are making some acceptance decisions. But jointly, they are going to determine in the model how quickly they match and how does the matching rate differs by the empirical proxies of supplier density and empirical proxies of buyer density.
Okay. Yuhei, can I ask a question to help me here? Isn't the third parameter, wouldn't a very standard model have that equal to 1 and then the lambda equal to 0? Is that right?
So nu is equal to 1. So I don't know what you mean by standard model. Standard, I guess,
if there was no kind of supplier, benefits of this density of suppliers, wouldn't you have just gotten a 1 for nu and then a 0 for lambda? Am I correct in that?
So nu, I agree. So nu is equal to 1 means that your matching rate doesn't depend on that density.
Yeah, so that's lining up with your fact that the buyer density was pretty close to 0. So that you pretty much left the first one alone at 1. But then you hiked up the second one from 0 to 0.59 based on the regression that you were emphasizing the most at the beginning of the talk, right?
Exactly.
I see. Okay, yeah, I think that makes sense.
And just to complement Sam's point, the standard model doesn't have a matching frictions, and one of the so it's a little bit hard to translate whether lambda 0 means.
I meant standard model in terms of standard search model.
Standard search model.
Like a labor search model, if you had twice as many buyers, wouldn't you get twice as many? Well, actually, maybe I'm not right.
Yeah, so labor search and matching, it's typical to assume lambda plus nu is actually sums up to 1. And there's and they said lambda, there's a literature of estimating matching function in labor search and matching context, and I don't know the typical estimates on the top of my head, but that's they set their own parameters.
Don't they tend to do half and half?
What? Sorry, what was the question?
Don't they tend to have half on each side?
Yeah, that's what I was going to say, but I think people are using micro data to estimate these parameters more seriously. So I don't know.
I think the old-fashioned literature had them at half and half. But
okay, yeah, that makes sense.
Yeah. Okay, well, are there any other questions? I don't want to cut off things too early, but this is very, very good. We got like a seminar after the seminar.
Sorry, that's yeah. I had to manage that time better, but I hope I am glad that I was able to convey all the message.
Worked
Yeah.
out the best.
Yeah, thank you. Thank you.
Yeah, thank you
Yeah.
very much, everyone, for all the feedback, and please send me if you have any other additional comments.
All right, bye.
Thank you very much.
Perfect.